Chapter 4, Section 3 is about angle relationships in a triangle. So by the end of this lesson, you should be able to find the measures of interior and exterior angles of a triangle, and you should be able to apply theorems about the interior and exterior angles of a triangle. So here's the first theorem. The triangle sum theorem says that the sum of the angle measures in a triangle have to be 180. So the measure of each of these added up needs to total 180 degrees every single time for every single triangle. So let's prove it. So we're given this triangle ABC, and our job is to prove that the measure of angle 1 plus 2 plus 3 gives us 180 degrees. Now the proof of this triangle sum theorem is going to use something called an auxiliary line. An auxiliary line is just a line added to a figure to aid in a proof. So we are going to do our two-column proof with our statements and our reasons. And let's start with triangle ABC, and that's given to us. And then we have to talk about this auxiliary line. And this auxiliary line L, we're going to draw parallel to AC. So draw line L parallel to AC. And the reason we can do this is because of the parallel postulate. And if you remember that, the parallel postulate says that through any point, and this time we pick point B, that's not on your line, you can draw one line parallel to it. So this line down here, AC, we picked a point that's not on line AC. We picked B, and we drew a line through it that's parallel to our first line. So if it's parallel, that means that we can talk about how these angles are related. So sometimes it helps to kind of draw the line out a little further. If we think of this line here, BA, as a transversal, we know that angle 4 and angle 1 have to be congruent. And that's because of alternate interior angles. And then the other one that we're going to use is the one on the other side, this line through BC. If that becomes our transversal, then 5 and 3 have to be congruent for the same reason. Now we can't use the whole congruence thing, but if two things are congruent, that means that their measures have to be equal. So the measure of angle 4 has to be equal to the measure of angle 1, and that's by the definition of congruence. And same thing with angles 5 and 3. So now, go back and look at what we have here. We know that because this forms a line, that those three angles have to add up to 180. So we know the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 has to add up to 180 degrees. And that's because of the definition of a straight line. And now we're going to do some substitution. Remember, our goal is to prove that 1, 2, and 3 add up to 180. So if I know that 4, 2, and 5 add up to 180, I can substitute. Angle 5 and angle 3 are exactly the same, so we're going to plug that in there. And angle 1 and angle 4 are exactly the same, so we're going to plug that in there. So this becomes the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 has to equal 180 degrees. And that's by substitution. And there you go. We have proved that the angles in a triangle add up to 180 degrees. And in class tomorrow, we're going to do a proof that you can actually see. So let's do an example. After an accident, the positions of cars are measured by law enforcement to investigate the collision. Use a diagram drawn from the information collected to find the indicated angle measures. So the first one we got to find is X, Y, Z. So angle X, Y, Z. We're finding this guy right here. So this forms a triangle, triangle XYZ. So we know that all of these angles have to add up to 180. So since we already have 62 and 40, this has to be whatever else we need to add to 180. So we know 62 plus 40 plus whatever this is, we can call it X, has to add to 180 degrees. So if we combine these, we can see that X has to be 78 degrees to make that work. And then you can double check this. Add 78, 62, and 40, and you should get 180. Now let's find the next one. We are asked to find YWZ. So this angle right here. So in this little sliver of a triangle, it tells us some information. It only tells us that this is 12 degrees. But because this is 62 right here, we know that this has to make up the rest of 180. So if I do 180 minus 62, I end up with 118. So this one has to be 118. And now if I know that, I can add 12, 118, and whatever this is, this X, and they have to give me 180. So 12 plus 18 will give us 130. And then we can see the X has to be 50. So we're going to talk about corollaries next. So we have postulates, which are things that we don't need to prove, we just accept them. Theorems, which can be proven, and then corollaries. And corollaries are theorems whose proof follows directly from another theorem. So it's kind of like, as a result of this theorem, we also know this stuff too. So I like this definition a lot. It's a proposition that is incidentally proved by proving another proposition, or an immediate consequence or easily drawn conclusion because we already have a certain set of facts, or a natural consequence or result. So these are corollaries from the angle sum theorem, which remember says all of the angles in a triangle add to 180 degrees. So because of that, think about a right triangle. By definition, if you're a right triangle, you have a 90-degree angle here. So that means your other two angles have to add to 90 degrees to make a total of 180. So the corollary says the acute angles of a right triangle have to be complementary. Because remember, complementary means adds to 90 degrees. And then the other thing that follows the angle sum measure is that you have an equiangular triangle, three angles that are exactly the same. That means each of them have to be 60 because you have only 180 degrees to work with. If you divide by 3, because they're all equal, they each have to be 60. So the next definition we need to talk about is what is interior, exterior, and remote interior. So if we look at this triangle, we have angles 1, 2, and 3 on the inside, and then angle 4 on the outside. We know that angle 3 and angle 4 are a linear pair because of this line that's drawn out here. So the measure of angle 3 plus the measure of angle 4 has to equal 180 degrees. And then we also know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 has to be 180 degrees. So we name these. If you're on the inside, you're obviously an interior angle. On the outside, you're an exterior angle. And we have things called remote interior angles. So if we're looking at angle 4 on the outside here, we don't want the angle that's right next to it on the inside. We want the ones that are far away from it. And those are the remote interior angles. Like a remote location is out in the middle of nowhere. So the exterior angle theorem says the measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. So here it's saying that if you add up angle 1 and angle 2, you get angle 4 out here. So we're not going to do a whole 2-column proof, but let's just make a plan. So back here we said the angles 3 and 4, because they make a line, have to equal 180 degrees. And then we learned that the angles in a triangle all have to sum to 180 degrees. So because of both of these things, we can kind of use substitution and say that these two things have to be equal. So a plan for a proof, we're going to use linear pair theorem and angle sum theorem to say that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180, which equals the measure of angle 3 plus the measure of angle 4 because of the whole linear pair theorem. And then if you look, because we set this equal to this by some substitution stuff, both of these have the measure of angle 3 in them. So we can use the subtraction property of addition to kind of cross those off, and we get the exterior angle theorem, that if you add 1 and 2 together, you get 4. So let's do a problem. Find the measure of angle B. So we need to find this by the time we're done. And they give us some information, but they give us A, B, and C here. So we need to use the exterior angle theorem and come up with a nice equation. So we know that 15 plus 2x plus 3 has to equal the outside, the 5x minus 60. Because remember, the exterior angle theorem says that if you take your alternate or your remote interior angles and add them up, they equal your outside angle. And then we just have to solve. So if I combine like terms here, and then we got to put all of our x's to one side, so let's move them over here. And then add 60 to both sides. So we get 78 equals 3x. And if we divide both sides by 3, 3 goes into 7 twice with 1 left over, 3 goes into 18 6 times. So we get that x equals 26. Now that's not our answer, because remember they asked us to find the measure of angle B. So I'm going to come back up here and plug 26 in. So 2 times 26 plus 3. 2 times 26 will give me 52. If I add 3 more, I get 55 degrees. Last theorem that we need to learn today. It's called the third angle theorem. And it says if two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles has to be congruent, because both triangles have to add to 180 degrees. So if you know this and this are congruent, and these two are congruent, then the only possibility for angle N and angle T is for those to be congruent as well. So let's use that one. In these triangles that kind of overlap, I know that angle G and angle H are the same, and the angle F and angle I are the same. So that means that with whatever degrees are left, angle K and angle J have to also be congruent. So I know that 4y squared has to equal 6y squared minus 40. So if I want to solve this, I'm going to subtract 6y squared from both sides. We get negative 2y squared equals negative 40. Because this is a y squared, we're going to have to undo that square with the square root. So let's get y squared by itself. So I get y squared equals 20. And to undo that square, take the square root of both sides. And we end up with y being a decimal, since this isn't a perfect square. And we get 4.47. So again, that's not our answer. That just tells us what y equals. So we have to find the measure of angle K and the measure of angle J. Now they should be congruent. So let's just plug this in once. And remember, we're going to square this, and we just undid the square, so that means we're going to get 20. And 4 times 20 will give us 80 degrees. So we don't need to know the measure of any of these angles down here, as long as we know that these two have to be congruent. So you should be able to find the measures of interior and exterior angles, given some information. And then you should be able to apply all the theorems that we just learned. Make sure you write down any questions you have, and we can go over them tomorrow before our lesson quiz. Have a good night.